our last lecture of the unit deals with electrons and energy, some quick review of physical science stuff. Your wavelength is the difference between your crest to crest or trough to trough, depending on how you want to look at it. The frequency is how often a wavelength travels. And amplitude is the height of your crest. Your peak is where it's at the top, and again, your trough is at the bottom. And of course, always pause and write down stuff. Next thing we're going to talk about is the electromagnetic spectrum. Remember that you're in your visible region, that's your Roy G. Biv. In the visible. And you can look at the electromagnetic spectrum and look at things as far as the wavelength they are, their frequency, and even how much energy is involved. We're going to actually do some calculations with all three of these measures. This is just a spectrum that I found that kind of gives you an idea of what's going on. To help you remember what is on which end, you have your radio waves are on your red side, and your gamma rays and everything, ultraviolet rays, are on your violet side. So that kind of helps you keep in mind, are they shorter or longer? And a shorter wavelength means it's going really, really fast versus how long they are in that specific space. You actually see how electrons are emitted all the time. You have played with light sticks in your life, and those are chemical reactions that are causing the electrons to excite and let off their individual lights. You see them in fireworks all the time, and we're actually going to do, if you haven't already, the flame test lab so that you will be able to kind of identify what element is involved based on what light is emitted. And each element has its own atomic spectrum. That's what this is showing. It's showing you three different elements with their own atomic spectrum. This is how we know what elements exist in the universe. It's based on very expensive equipment that they use to figure out what energy is being emitted by the elements. Let's do some quick calculations. And we have two formulas related to electromagnetic spectrum calculations. You have your speed of light, and speed of light is represented by the C. Your lambda is your wavelength. The V is frequency, and it's the same in both equations. E stands for energy. And then the H is Planck's constant. And the constants you will always be provided along with formulas. We're more concerned that you know how to use the formulas and manipulate them than we are that you remember what the formula itself is. So if I wanted to find out the frequency of a green light, which has a wavelength of 4.9 times 10 to the negative 7, that means I'm going to end up using this formula because the wavelength and frequency are tied to your speed. So substituting in our numbers, it is 3 times 10 to the 8. It's our C, always our C. Our wavelength is 4.90 times 10 to the negative 7. And frequency is what we're looking for. So when we solve this algebraically, dividing both sides by wavelength, we find out that our frequency is 6.12 times 10 to the 14th. And that's S to the negative 1, which is the same as 1 over S. Because what happens is our meters end up canceling each other out on that calculation. If we want to know how much energy was involved in that exact same wavelength of energy of light, then we can plug it into this formula where E equals Planck's constant times the frequency that we just calculated. We would find out that the energy involved is 4.06 times 10 to the negative 19, and energy is always in joules. Or we can also use the equations backwards. They are interconnected by that frequency. So if I know how much energy is involved, I can find out the wavelength. Just by substituting into our E equals, on this problem, I'm given energy, and I'm looking for frequency. So that means that I'm going to use this equation first. I'm going to substitute in my 1.73 times 10 to the negative 15 is equal to the 6.626 times 10 to the negative 34. And frequency is what we're looking for. And by solving it algebraically, just like you would in math class, we find out that the frequency is 2.61 times 10 to the 18th. That's negative 1, because when you look at your units, you have joules seconds and joules. You would have divided by the joule seconds. The joules cancel out. So you would have your 1 over S, or S to the negative 1. You'll also hear frequency in hertz. And that's another way of saying frequency, as hertz versus S to the negative 1. And from that, we can use our C equals equation to solve for the wavelength, because we know that C is always 3 times 10 to the 8th meters per second. So I can find my frequency knowing that I have a wavelength, find the wavelength because I know my frequency is 2.61 times 10 to the 18th. And so when I solve that algebraically, I find that it is 1.15 times 10 to the negative 10 meters. If you're getting a wrong exponent as your answers, that's because you're not putting your scientific notation numbers in parentheses when you're dividing them. And we can work on your calculator skills later. If you have any questions, ask me in class.